Historical background. For hundreds of years, scientists were curious to know about the smallest parts of matter. Rishi Kanad, in the 6th century BC, said that every object is made up of indivisible tiny particle. He called it as Paramanu. A Greek thinker, Democritus, postulated that matter is made up of very small particles, that is, atom. In approximately 430 BC, Democritus coined the term atomos, which means uncuttable, or the smallest indivisible particle of matter. In 1803 AD, John Dalton put forth his celebrated atomic theory. According to him, matter is made up of small particles called atoms. Atoms cannot be created, divided into smaller particles, nor destroyed in the chemical process. As more scientists worked on understanding matter through experiments, they discovered that inside the atom there were other particles called electron, proton, and neutron. This led to many other theories on the atom. Thomson's theory of atom. John Thomson, in 1867, developed the idea that atoms are made up of negative electrons embedded in a gel of positive charge, a plum pudding model. These are the electrons, and this is the positively charged pudding. This is how a positive ion is formed. This is what happens during conduction of electricity. Thomson may be described as the man who split the atom for the first time. Rutherford's model of the atom. Rutherford overturned Thomson's atom model in 1911 with his well-known gold foil experiment, in which he demonstrated that the atom has a tiny, massive nucleus. Rutherford designed an experiment to use the alpha particles emitted by a radioactive element as probes to the unseen world of atomic structure. Rutherford's scattering experiment. Rutherford beamed alpha particles, which were doubly charged helium ions, through gold foil and detected them as flashes of light or scintillations on a screen. When alpha particles collide on the screen, it scintillates. The gold foil was only 0.00004 centimeter thick, meaning a few hundreds of atoms thick. He expected the alpha particles to pass through with relatively little deflection and strike the fluorescent screen directly behind the foil. In fact, what was observed was the following. Most alpha particles passed straight through the gold foil. Some of the particles deviated at small angles. A few were scattered at large angles. Very few bounced back towards the surface. Using these observations, he formulated the theory of an atom. According to this theory, 1. An atom has a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated. 2. The light negative constituents, called electrons, revolve around the nucleus in paths called orbits. This is much like a solar system where planets revolve around the sun. Rutherford's model has certain limitations. It could not explain how the moving electron would remain in its orbit, especially when it was a charged particle, and therefore it would accelerate due to its movement, finally moving closer to the nucleus and drop into it. The atom would not be stable, which in turn would mean that the matter would not be composed of unstable atoms. Niels Bohr's atomic model. Nobel Prize winner Niels Bohr in 1922 revised Rutherford's model by suggesting that the electrons were confined into clearly defined orbits. They could jump between these orbits but could not freely spiral inward or outward in intermediate states. An electron must absorb or emit specific amounts of energy for transition between these fixed orbits. Discovery of the neutron. John Chadwick in 1932 discovered another particle inside the atom. It had no charge and its mass was almost equal to the mass of the proton. It was present in the nucleus along with the proton. He named it as the neutron. Students, let us now describe the atom systematically. An atom consists of a nucleus which contains protons and neutrons. Electrons revolve around the nucleus in fixed orbits. Imagine that the size of an atom is as big as the size of a professional cricket stadium. The size of the nucleus would be about the size of a cricket ball in proportion, and the size of the electron would be smaller than the size of an ant.